notice. We're going to have on, like yesterday, 30 or so minutes of me opening my pie hole, and then we have workshop activities, and so you might come in for the workshop activities, which would be great. Because you don't really necessarily need to have any of the prior knowledge to go to the workshops, because really where you can absorb in 30 minutes. So I'll give you all the information when you come back, if you want to come back. No big deal. We go out and check with our overlords to see how much of a, how much of a weight we need to have.
Yeah, I can. Oh, that's one. CEO can. Yeah, he's friends with, yeah. So I came to give us a demo, show me, no worries, James.
Perfect, great.
And.
I brought this cup of water so I could pour it into the computer for you.
Yeah. The Virginia Tech Corporate Research Center might not be very happy about that.
I can imagine.
I'm gonna get a little upset. I'm going to turn this TV off
Okay.
because it is not working.
No, I see the other one.
Yeah, the other one's there.
Yeah. So we're waiting for somebody to come in and tell you who I am. There she is.
She's.
No, he did not show up, but I'm putting a Band-Aid on.
That's always a good idea.
Hold on. It needs an issue.
Okay, that should do.
No worries.
Is the sound?
We found it working. No one else found it.
All right, we're gonna get started and just realize people will probably still kind of be
No worries.
filtering in.
No
a lot of
worries.
People at the registration table to still trying to check in, but thank you guys for coming and in person today.
Of
So
course.
glad to have you here. So this is Ken Davinian. We're so thankful to have him. He's gonna be speaking every day this week, except on Friday.
I'm not on Friday.
But Ken has just an incredible background in the space industry. And he'll tell you a little bit about it, but he has worked at the FAA, running the commercial space sector. He was vice president at International Space University. He was at NASA for a long time. And his background is in engineering. He'll give you even more specifics on all the things that he's done and is doing currently. But today he's going to be talking about space and human performance. So when we were thinking about health and life sciences, space has so many applications to so many different industries.
Okay.
And of course, there's applications to health and life sciences. So we're excited to have him, and I'm going to turn it over to Ken.
Thank you very much, Laura. So, the checks in the mail kind of thing. Thank you for that introduction. My name's Ken. I retired, so I have no official affiliation, other than that I'm an adjunct here at Virginia Tech. So I've been adjuncting for the last 5-6 years with a guy named David Townsend, who related by blood to Laura Townsend, but they've got other familial bonds. So, like she said, I've been in the space industry for over 40 years. I'm sort of taking a sabbatical a little bit right now. I retired actually from government, 34 years of government service a couple of years ago, jumped into my VP role at ISU, which I just recently gave up. But so I'm sort of in between, I'm just trying to figure out which way is up right now in my life. But Virginia Tech is kind of the center of my focus right now. And so I'm really happy to be here at Game Changers Week. And so I appreciate Laura being here. As she mentioned, I worked at NASA, what was called NASA Lewis in Cleveland from 1983 to 2001. During that time, they sent me to a place called the International Space University, where I was a participant at their summer program. And then that was in 1989. And then in 1997, NASA seconded me and my wife for 3 years to Strasbourg, France, to work with ISU to help put on their 10-week program called the Space Studies Program. We did that when we came back. I came back to NASA in 2001. It was called NASA Glenn at that time. And then I actually resigned because we got an offer to move to Berlin and work on a large airship project. That fizzled out as many airship programs do. It seems like a stage. One of the critical stages in the life cycle of an airship program is bankruptcy. So once that happened, I went and worked for an organization called the X Prize Foundation. And this was a $10 million prize to offer to the first non-governmental suborbital flight that could be repeated in 2 weeks and could carry more than one person, 3 people. Did that for a while, ended up going back to NASA, running their prize program, and did that called Centennial Challenges from 04 to 08, at which time the FAA, Office of Commercial Space Transportation, asked me to come and join them, and I did that, and I led their research program there. And we're going to talk a little bit about the research program, because as you'll see in my training, aerospace engineering, mechanical engineering, and then PhD in business, I'm not a doctor, right? I am not a doctor. I have no medical training. What you're hearing is basically a person that's been exposed to this stuff for the last 3 decades or so, telling you what I know. But then what we'll do is I'll tell you a little bit about the research that we did in my research center management role that I had in the FAA. But first, overview. This is what we're going to talk about: problems and impacts, right? You've got the human, but not just the human, you've got the human in space, right? So there's a whole lot of issues that you're going to encounter. Number one, radiation exposure, just being there. But number two, you're also going to have bone density loss and osteoporosis. You're going to have the psychological challenges that come along with long duration space flight. You're going to have effects on the eyes, on the heart, on the muscles. And then, in fact, I didn't know where to point on the body for immune system, but ChatGPT said you can almost point anywhere on the body and gave me specific points. And the leg was one of them. So the immune system also gets affected. So we're going to talk a little bit about all of these things. And then we're going to talk about what kind of technological innovations we've generated to deal with these and to mitigate the issues, and then who's doing them. And then we're going to have a workshop, and we'll see how the workshop goes, because it's a little bit involved. But having said that, I want to just quickly, and I'm not going to spend a whole lot of time going over each of these, 7 different types of issues that are out there. And I'm sure there's more, but these are the top main categories of threats and issues that the human body will encounter during space activity. And the first one, of course, is radiation exposure. And the major issue is the gamma radiation, right? Because these are little bullets flying around, and they can actually damage your organs, and it can damage the bottom your body, as well as damaging the electronics on the ship. So there's a whole lot of issues dealing with radiation, and it can cause DNA damage, can't increase cancer risk, has all these different problems that are shown here. And you do it by and you treat it by shielding the crew from radiation, shielding the electronics from radiation. So somehow putting a shield around the ship so that the vehicle and the people are protected. There are pharmacological countermeasures, and then there are also other types of countermeasures that can be enacted. In terms of effects on the eyes, so this is really noted in long duration missions where you've got, whether it's gamma cosmic radiation, or you've got some pressure changes in the eye area there that causes problems with focusing, vision impairment, and all these different things that impact the eye. Bone, we've heard about bone loss and osteoporosis like symptoms coming from folks that have endured long duration travel. There's reduced bone mineral density. And this comes, it's like osteoporosis, but it comes during prolonged exposure to microgravity. So, it's caused by calcium imbalances and altered hormone regulation. You've got decreased bone density, mobility, and operational efficiency, but increased recovery time, fracture risk, and long-term health risks. So this is why astronauts will end up exercising. I think the minimum right now is 2 hours a day. On Mir, way back in the 1970s, when Mir was up there, the Russians were exercising on the order of 4 hours a day, because they've been up there for so long. So having the proper equipment and different ways of exercising in a close environment in microgravity is in itself a real challenge. One of the most fascinating issues are the psychological challenges. When I was helping to run the summer program for ISU, we would bring in people that went to Biosphere. I don't know if you know about Biosphere. It's out in Arizona. It's a 2-acre enclosed bubble, basically, that 8 people lived in for 2 years. It had a bunch of different biomes inside. One of the company that sent us to Berlin, two of the people in that company were inside the Biosphere for 2 years. And in fact, one of them, Tabor, is the guy that designed, built, and operated the environmental control and life support system, the lung, and all the activities going on inside the Biosphere. And it was Tabor basically that worked with the scientists to figure out where the oxygen was going, why they were getting the oxygen loss that they're having. It was being absorbed by the concrete. There was an incident very early on in the Biosphere when a woman came out because she had cut her finger or cut off her tip of her finger. So she came out to get medical treatment and went back in with some extra computer hardware, which kind of violated the material enclosure of the Biosphere. And that woman's Jane, so she was the husband of Tabor. And so I worked for both Jane and Tabor, and they're both incredible people. And but having Tabor come and talk to the class about the psychological challenges, what was super fascinating. And even though each of those crew members in Biosphere had access via phone to psychologists at all times to talk through what's going on, they still ran into breaking up into individual groups, the management versus the workers, and there was all this animosity going on. So psychological challenges on a long duration trip, and a trip to Mars is going to be 6 months at a minimum, right? And so the volume is going to be limited. You're going to have a bunch of people around you. If you talk to Elon, it's going to be 100 flying there at a time. If you talk to Lockheed Martin, it's going to be 4. But there's still going to be interpersonal issues, and we're all very familiar with that. So there's a lot of different causes there, and a lot of different treatments. And again, to me, this is more like a book report of kind of these are what's going on in the space environment, the effects on the body. A lot of this, I'm sure a lot of the space docs that I'll talk about in a little bit would be much better at presenting than I could. Of course, there's cardiovascular health, deterioration due to prolonged microgravity. And so the treatments here are exercise again, nutritional supplements, drugs, and mechanical countermeasures. So muscle atrophy is another one. Just you're not in gravity, so you're not counteracting the force of gravity. Kind of doesn't feel like it when you're here in 1G, but in space, there's 0G and there, so that you end up in decreases in muscle mass and strength. And especially for the muscles for body posture, it's really interesting. I just saw a video talking about, is good posture does it even really matter, right? It seems to be more connected to sociological perceptions of evolution than you think of the evolution drawing that you see the ape or the people coming on and getting taller and taller and taller. So, but those are the muscles, the body posture, holding your body upright, are the ones that get affected most. And of course, exercise is the major countermeasure so that you can counteract the loss in muscle mass and strength. And there is an increase in injury risk, which could be mission critical if you're on a long duration mission. I mean, this is one of the reasons why some people prefer going to the moon first than trying to go to Mars. The moon is only 2 or 3 days away, right? So if something bad does happen, that's not, super time critical, you can get somebody home in time. It's feasible at least to get somebody home in time. And so next is the immune system function. So the problem here is wrong. That's a cut and paste mistake on my part. It's supposed to say basically that the immune system it can be suppressed quite a bit. So, and this is due to extended microgravity, fluid shifts, And this could really increase the chances of infection, inflammatory response, healing time, and all these different things. And so again, between nutritional support and using different drugs, stress management, and exercise regimes, try to keep the immune system functioning. It's really kind of weird how so many functions in your body are affected by microgravity, which you might not have even thought about. And we're going to talk about that in a couple minutes here, because the problems that we're noticing here are pretty much all related to long duration space flight. So, what about these microgravity or these suborbital flights that are going on right now? Is there an effect on the pilots that will be going from 1G up to 0G and back down to 1G over and over and over again? And so we're going to talk about that type of research in a couple seconds. But first, I tried to talk about what are the technological improvements for all these different types of losses. And there are a lot of different ways of, creating new shielding. Water is a fantastic radiation shield. So there have been ideas about just enclosing, the vehicle with a sheath of water, or different types of active shielding, having some sort of electromagnetic fields that would be able to counteract or at least repel the particles coming in. Radiation exposure for lunar surface, the radiation shielding that is readily available is the regolith, the dirt on the lunar surface. So, there's just been recent confirmation of channels, caves, lava tubes underneath the lunar surface. From Lunar Reconnaissance Orbiter, we've noticed, and I guess that Lunar Reconnaissance Orbiter is the new one. They've been able to find different tunnels where the roofs have caved in on top of these tubes. So you see the crater, the hole going down to this lava tube. So that's one of the possible places where astronauts are going to be able to live, is underground because of the radiation shielding that the regolith provides. Bone density loss, there's vibration therapy, there's enhanced resistance. That's just basically bands and elastic bands and stuff. And then different types of drugs. There are a lot of psychological challenges. So virtual reality, real-time psychological support, and sleep management is another way to try to deal with that. Monitoring systems and lower body negative pressure devices. So these are devices that help to keep the blood toward the top, toward your head. So your brain doesn't lose blood. Because of microgravity, the blood will kind of just pool around. It's not fighting gravity. And so you want to make sure that there's enough blood up in the head by putting pressure, either high pressure on the legs that forces it up, or lowering the pressure around the legs that pulls the blood down. And then artificial gravity has been something that's been talked about. The team project that we did in 1989 was to develop a variable gravity research facility, creating a spinning facility that could create different levels of artificial gravity. And again, advanced resistive exercise device, functional electric stimulation, and also artificial gravity for muscle atrophy. And then for the immune system, trying to just keep the air filtered better and sterilized better so that you don't get any type of infection. Radiation shielding materials, of course, to try to mitigate the effects that radiation has on the immune system, and then other types of drugs and probiotics. So those are sort of the technological solutions. And then that's what is being done, but who's doing that research? So typically, you have the NASA HRP, Human Research Program. And it's a big, big program. I don't think I'm talking out of school when I say it's about $120 million a year, right? Maybe it's like 144, but NASA's doing it. Of course, ESA, Space Medicine Office, is also very involved, as are other countries focusing on humans in space, which is Roscosmos, most definitely. Japan has started doing it. They've got a couple astronauts that have flown to ISS with the US. CSA, Chinese National Space Administration, as well as ISRO, the Indian Space Research Organization. So a lot of these folks are doing this work, but that's on the governmental side. So who's doing this sort of stuff for commercial space on the non-governmental side? And at first you might say, well, what non-governmental? And all space is governmental. And part of the X Prize, when I worked at the X Prize, part of the goal there was to break this space equals NASA mentality, because space doesn't have to equal NASA. And we're seeing that now with Elon flying with SpaceX, flying a whole bunch. So when I was at FAA, I ran a thing called the FAA Center of Excellence for Commercial Space Transportation. So now this was 10 universities, started out with 9. We added Baylor College of Medicine near the end. There's 10 universities that were basically vying for a piece of $1 million a year. Our budget was not very large. But we ran from 2010 to 2022. It was supposed to end in 2020 because of COVID and some other funding issues. We delayed the close date by 2 years. And basically, the goals were to do research, training, and outreach on commercial space sort of research activities. And the whole point was to increase national competitiveness, develop specialized and advanced skills in the research students and stuff. There's a whole bunch of studies that says the return on investment of research is actually less than 1. I mean, by definition, research is you don't know what you're doing. You don't know what you're getting. The ratio is always going to be less than 1. You're always going to put in more than you get out. But the students that you train absolutely go out into society, and whether it's in the space industry or wherever else, they're going to go out and become productive members. So there's a positive ROI on the students that you train. So to me, that was just reemphasizes how it's always about the people. And so I really enjoyed the 12 years of just interacting with students and whatnot. And one of the nice attributes of the COE was that it was a one for one match on all U.S. government funds. So if we gave a $20,000 grant or $50,000 grant, they would have to at least on paper show a $50,000 match or a contribution by somebody else. So, and you can see that we had universities from, well, I'm showing all the different universities that were affiliated in any kind of way, but the main universities were Stanford, New Mexico State, and New Mexico Tech. CU Boulder. I talked about Baylor College of Medicine, which is in here somewhere. And then there's UTMB here in Galveston, this is where all the NASA docs are. And so they were on our team. So that was really exciting. And then over here in Florida, we had UCF, University of Central Florida, University of Florida, Florida Institute of Technology, and Florida State University. So those were the primary universities. But we had affiliations with organizations in Germany, DLR, and a whole bunch of other universities and companies around the country. And what we did was we divided all the research we did into 4 areas. There was operations, space traffic management and operations. There was technology and payloads. So this is engineering. This is operations. This is engineering, physics, and engineering. Human spaceflight. So this is the life sciences stuff we did. And this was the social sciences, markets, policy, law, regulation. And what we're going to focus on, one of the major research topics, actually like 2 or 3 tasks, one of the major topics in here that talk to aerospace physiology and medicine. But there's other different aspects of human spaceflight, the training, the environmental control and life support, habitability of human factors, as well as human ratings were also part of the typology of the research we ran. So the different, and I'll mention, you see right here, all the research from all 12 years has been summarized into one handy volume, which is 900 pages and 5 pounds. And anybody who's irrational enough to want 5 pounds of paper, my wife told me to get these things out of the basement. So I've got 4 more left. So if anybody wants one, you're more than welcome to it. It's a lot of great fun, but I needed something to show for my 12 years at AST. So that's good. So anyway, so the research that we did was on all these different topics, everything from creating a database, risk management approaches, medical standards, and SFP stands for spaceflight participant acceptance criteria, wearable biomedical equipment, testing and training and hygiene profiles, minor injury severity scale. This was interesting. How do you evaluate the severity of an injury? So there was a lot of work done on that, EMI and radiation effects, suborbital anxiety assessment. We're going to talk about that in a little bit more in pilot training, cabin survivability, commercial space occupational medicine standards. And then CU Boulder actually worked on human rating definitions, risk assessment, human factors of the ecosystem, and then also mapping the life support system. So a lot of people say, well, what's the difference between space research in life sciences and commercial space research? Well, this is a chart that Richard Jennings, who was the doctor from Texas, to all the private individuals that went up to space station. Starting in 2001, Dennis Tito went up to space station for 2 weeks. And since then, there were 7 other people went 8 times to space station. And Richard Jennings was the doctor for all of them. And this was one of his charts. And I thought it was great because he talks about what's the difference between governmental and non-governmental space. Well, first of all, you've got the baby bottle, the Coke bottle, the beer bottle, and the IV drip, and representing different stages of life. And the government, NASA and the DoD, focus on the beer bottle phase. You know, these are young individuals, they're fit, they've been trained, you know, they're good physical specimens. And that's who they focus on. Whereas in the commercial world, you know, we don't focus only on the people who are fit, we're looking at anybody from 16 to 90. You know, that might want to go. And so the scope of the problem is much larger. And I just thought this was a good example of how space research and government or commercial research can be a little bit different at times. So some of the questions that we were asking was, how do non-career astronauts tolerate increased G-force acceleration profiles? And again, this is something that NASA is interested in how people are influenced by G profiles, but only people that are physically fit that can, you know, withstand it better. Whereas for commercially, we care about how it affects a lot of different people. And then also, how do individuals with controlled chronic medical conditions tolerate spaceflight? So if you had a neck or a back injury, if you had diabetes, if you had asthma, if you had an implanted device like a pacemaker, your chances of being selected as an astronaut by the government is probably pretty darn low. But these are the customers. You know, most customers that fall within this range have something wrong. You know, that's why most of us will never be a government astronaut, but we can pay our way into space. And so what happens when you take people with common diseases and put them into these acceleration profiles? What happens? And what are the diseases of greatest concern? So ultimately, can normal people who aren't highly trained, safely take a space flight? And it was really interesting. What we did was we worked with an organization called NASTAR. This is a subsidiary of a larger company called ETC, and NASTAR is outside of Philadelphia, and they have a big centrifuge. And they do training, survivability training. They have a hyperbaric chamber, they have a dunk tank where, you know, you could do like, you know, capsizing kind of exercises and whatnot. And then they have this centrifuge. And so the goal of this research was to take subjects that have defined disease states and put them under the G loads, the G loading profile that you would expect in a suborbital flight. Now, this is where the difference between commercial and non-commercial comes in, because NASA has never cared about suborbital flight. Well, I wouldn't say never. The first 2 flights of Mercury were suborbital, but since then they've never researched the effects of repeated change from 1 to 0 to 1 G. A pilot would do that many, many times over the course of their career, and sometimes in rapid succession. And we don't know how that affects people because NASA's never looked at it. But in the commercial world, this is something that's going to be really interesting. So yeah, we were looking at, again, cardiovascular disease, hypertension, diabetes, pulmonary diseases, like asthma and whatnot, spinal disease. This is what freaks me out, you know, neck and back injuries. The anecdote that we have here, one of the women that partook in the study, so there was a big sign-up thing, people could volunteer. One of the women that signed up for the study was actually one of my interns. This is a woman who runs a fitness facility. She runs a gymnastics training course down the street from Olga Korbut. People know who Olga Korbut was, the Russian gymnast. But she's in, I think she's in Tulsa, Oklahoma. She runs this big gymnastic thing, super fit. She's about this tall, you know, a bundle of energy kind of thing. She took the first centrifuge ride, and she said it was like an elephant was sitting on her chest. She's super fit. And so she opted out of the second flight because that was just on the ascent. So in the ascent, she was like freaking out and she couldn't quit halfway. So she had to come back down, and you experience how your G load's coming down. But then she opted out of the second flight. And it was really interesting, the results that came out of this. Ultimately, it looks like I'm not going too much into it more. Ultimately, what happened was they found that, well, I'm sure I've got more, so I'm going to hold the thunder there. But anyways, here's if you want to know all the details of all the tasks, you know, you can absolutely just download this from the web. The site is coe-cst.org. It's the first thing on that page. Rather than 900 pages, you can just get a nice PDF from it. But if anybody does like hard copy, we definitely have a couple for you all. And it covers all the research, not just the life science research there. Oh, I guess I'm not, let me tell the rest of my story. Where was I? So I was talking about how, we had all these people, we had about 300 people that went through the centrifuge testing. And it turns out the only people that withdrew from the study, they weren't, they might have had neck injury or back injury, whatever that thing was. They didn't withdraw because they were afraid that their back injury or heart palpitations would get worse. They would withdraw for something totally different. So out of the 300 or so people that they tested, there was like 6 or 7 that withdrew by themselves. And so they decided that anxiety was going to be a major determinant. So we did a subsequent research task to try to determine, is there a way to screen out people that might suffer from, elevated anxiety that would make them kind of freak out? Because last thing, if you're paying $250,000 or these days, $500,000 to do a suborbital flight, and the person next to you who's never gone through training, they freak out and start puking all over everybody. No, I want my money back, kind of thing. So I signed up for a puke fest. So it's just really interesting how the psychological factors started becoming more into play. None of the people were disqualified because of their physical wellness. So even at, they had some elderly folks going through the testing, but never did they pull out, did folks pull out for the actual problem that they had. So it seems like more people can fly safely, at least suborbitally, no problem. This research was highlighted at the 2014 Aerospace Medical Association ASMA conference in Denver, SRO plenary panels and all this sort of stuff. They won all the awards for best paper and all that kind of stuff, because nobody's ever looked at this. NASA's never looked at this. And now and then 2014, 10 years ago, with the vision of suborbital flight coming, everybody was so jacked. And it turns out that one of our docs, Jim Vanderploeg, was the chief medical officer for Virgin Galactic, right? Tara Castleberry took over that. She was one of our students. Charles Mather. We have all these people that won a bunch of nice awards. We're doing great work, and finding space doctors that are moving out of the NASA realm and into the commercial realm is fairly rare. So we're really happy about the kind of reception that they were getting from the community, from the academic community on the work that they did, because it was really, really good. So in conclusion to this part of it, there are many health risks, such as, what we all talked about, and these are the risks, and we talked about the causes, or at least I showed you different causes, impact, and treatments. And to be honest with you, with a Google search, you're going to find papers on all this stuff. So again, Ken's not a doctor. I'm just sort of regurgitating information to you. But absolutely, there's so much going on, and space medicine is a great field because there's so much stuff. There's so many ways to approach it. For example, pharmaceuticals in space, they deteriorate different over time than they do on Earth. So understanding what that means to the supply of drugs you need, or what are going to be the effects of a drug that's been deteriorated, that's been compromised if an astronaut takes it, is a big question. So I'm going to take a sip of water. I'm going to say, here's my contact information if you want it, for whatever reason. But what we're going to do is going to go into the workshop scenario after I take all your questions. Any questions so far? Yes, Laura.
So, it's interesting to me. I love the fact that they were doing research on people who aren't fit.
Right.
I'm thinking, I don't know if I could ever go up into space. I'm not fit enough. But it's funny because William Shatner went, right?
Oh, that's right.
And I'm like, so when you're talking about them doing research on the G-force, is there research happening to minimize the effect of people going up into space, like the force that they're feeling within the aircraft?
Right.
To make it more easier for people to be able to endure the takeoff. Because I'm just like, how did William Shatner go up there? And at his age, and be able to, withstand it.
Yeah.
And if your friend who is super fit and was like, I can't handle force, how did William Shatner do it? That's what.
Well, yeah, to me, the story about my friend, my intern, and her pulling out is hopeful. It's a hopeful, story, because even, just by looking at you, I'm not going to be able to tell whether you're going to be okay to fly, and this is where pre-flight training comes in, and William Shatner and the rest, all the new Blue Origin, New Shepard, participants, all of them go through training. All of them are exposed to the possibilities of, of low pressure, because there's a leak in the capsule or, high G's. So that they know what to do. They know about tensing their muscles and, trying to maintain blood flow to their brain. The flight profiles are the engine will be throttled up and down to maintain limits on these acceleration forces in all three directions, X, Y, and Z. I think it's X, Y, and Z. I forget what it is, but they worry about FX, FY, and FZ, and so they absolutely do that. There tends to be greater accelerations on the body, but for shorter periods coming down. So the profile can be controlled to some extent, but it just depends on the vehicle. William Shatner rode on the Blue Origin New Shepard, so that's a liquid rocket engine propelled rocket. So that has lower accelerations than a solid, or in this case, a hybrid powered rocket plane that is Virgin Galactic. So Virgin Galactic uses a basically HTPB. It's a basically tire rubber kind of core with nitrous oxide pumped through it, and they can light it. So that's called a hybrid engine, and they end up with a little bit higher acceleration profiles, especially on ascent. But they're taking off from 50,000 feet rather than from whatever sea level is, or near sea level for the Blue Origin. So yes, the answer is yes. They do worry about that because the human body can only take certain stresses. So this is why also you're not going to put a human on a solid rocket booster, which has super high acceleration rates versus.
Are you seeing a lot of space medicine? That's even something I hadn't even thought about, like in the medical field. My son was trying to go to medical school, and it's very competitive. And most of the time they're very focused on, care here and you have to pick a different field. But I haven't heard of anybody actually going into space medicine, like actually going into that field. And you brought up some really good points on medications.
Yeah.
How medications would be affected in your body, and even the breakdown of medications. I mean,
it's amazing what all the different effects. And so there's a lot of problems for these people to work on. This is why the HRP, the Human Research Program in NASA, is so, so active. And, $140 million is not, anything to sneeze at. So again, yeah, there are specific schools that work on space medicine. They tend to be around Houston because Houston, NASA Johnson Space Center is the Human Space Flight Center for NASA. UTMB, I talked about, University of Texas Medical Branch, but also Baylor College of Medicine. One of the prominent doctors at Baylor is a guy named John Clark. His wife was on the Challenger act in 1986. So he watched his wife, perish, and so he's sort of been at the forefront of human spaceflight safety, ever since then. So Baylor is another big one. I imagine there are other space medicine schools around. We were dealing with UTPB or UTMB and Baylor specifically. So it's an active field. And at the International Astronautical Congress, where all these folks come together, they've got entire sessions on space medicine. So, and then ASMA, like I said, the Aerospace Medical Association is another one where all these docs get together once a year and show off what they've been working on. So it's a really interesting field. Of course, basic understanding or the basic curriculum in medicine is the first step. And so this would be a specialty, I suppose, that comes after all the years of residency and whatnot. So it's really kind of exciting. Yes, sir.
But I'd be off base in thinking that the benefits of training are 25% physical, but 75% feelings of preparedness to prevent.
I'll bet. I mean, how much, especially for a space, might say space tourist, might say passenger. What the FAA says is human spaceflight participant. They're not passengers. Passengers that have a reasonable expectation of safe passage. When I get on the plane, I think I'm going to walk off, but we're not guaranteed. The FAA doesn't guarantee that with a space flight, with a suborbital flight. So yeah, but you're absolutely right. Because how much you're gonna have 1 week of training, maybe, and how much are you physical? You'll be prepared for it. So like you said, it's psychological. You know what to expect. Your body's not really going to have been that conditioned from getting into a hyperbaric chamber once or twice, right?
So going to the gym for a week.
That's it. Yeah, I'm doing great. I'm such a gym guy, So yeah, it's just kind of normal for that. And it's amazing how much the psychology really plays into it. And it's really funny. There's an old anecdote when the Russians were joining the ISS program. There's a lot of high-level meetings, and the chief medical officers, of course, met. And you're talking about docs from the Russian side, coming from East Germany, as well as from Moscow, coming together. And they had a regimen where their astronauts had regular massage there. You know, and the NASA docs just couldn't, NASA just could not get their mind around that. So different cultural approaches to different types of medical treatments and stuff. So it's really kind of interesting mixing the cultures and seeing, you know, how the practices sort of migrate from one culture to the next.
One thing I sort of thought, like when you mentioned that people who pulled out of the study were basic anxiety, and then going back to that.
Yeah.
The biosphere thing, where there was animosity amongst what the 8 members, so.
Right.
If it is the trip to Mars where you're only sending 4 people as opposed to 100, and they're there for however long, isn't that small cohort, how do you sort of? I mean,
What?
teamwork is hard, especially when you're so isolated, and it's like.
You know, engineers tend to think of people like robots, right? You're sort of a pink squishy thing or light brown squishy thing that, you know, you have to make sure we give you enough air. You know, so, but here's the food you eat. But beyond that, they kind of, you know, make a lot of assumptions about how the interactions are going to go. But yeah, things get really tough really quickly. And I don't know, they do a lot of psychological profiling. They do try to match people up. They try to put them together in work teams ahead of time. You know, but things change over 6 months, you know, of course of, you know, a period of time. And you're gonna end up with conflicts, and because let's face it, especially in the governmental programs, you've got all these type A personalities, they're super capable. Their egos are probably, to some extent, rightfully inflated to some degree. And you put them all together in a box. As they go. And by the way, you're gonna eat powdered food for the next 6 months. So yeah, I mean, it's amazing how much the food and the cultural, psychological well-being are all tied together. So, you know, looking at it from the doc's perspective is sort of, again, very unifocused, but keeping the squishy big things alive is a big deal. And it's gonna be really hard, especially, you know, in these small cohorts that NASA is planning to send on these long duration missions. And so as crazy as Elon is as an individual, the plan to send 100 people at a time is ambitious. But I mean, yeah, people are gonna break up into cliques and stuff, but I think it's gonna be an easier group to deal with, especially once you get there.
That's what I don't know how feasible, I don't know much about it, but I think if you just the quantity of people, and I grant it, I just think like for the times, it's gonna be tough.
Oh,
I mean, this is a long mission, you said 4 and 6 months and however long to get back anymore.
And that's the problem, you know, that's the part of the Mars mission that's probably the least developed, is the psychological and the human factor part of it. Technology, I mean, Elon's ready to start building it tomorrow, you know, the technology is kind of there. You know, we've known how to get to Mars and we know what the problems are gonna be. Now it's just a matter of doing it. It's been fascinating to watch the Mars rovers. I watch a YouTube channel called Mars Guy, where he almost on a daily basis tells you what's going on with the different rovers. And it's really, really fascinating to watch that. So it's going to be real exciting once we, you know, get some people up there, you know, by creating the infrastructure, the biodomes and all that sort of stuff. There's companies on Earth that are working on that kind of stuff right now. So it's really kind of exciting to see what they're planning for human spaceflight. There are good aspects of the way NASA's approaching it, and I guess the international space community is approaching it, but there's also some negative aspects. I'm right now with SLS flying only once every 2 or 3 years. It's hard to get super excited in between the flights about what's going on. Whereas with Elon flying all the time, he's always had his goal set for Mars. So every step you can see kind of moving toward Mars. So we're waiting for, you know, test flight 5 coming up of Starship, and that's going to be a real big, you know, you see the steps that he's taking one by one to put that action or that plan into action. So it's really kind of cool. So let's see, we're supposed to do workshops right now. People want to just keep talking, or do you want to do a workshop?
Well, how much time is the workshop?
Well, so let me tell you what the workshop is. How about that? So the workshop I came up with is that it's a mission scenario where something goes wrong. So what I would do is I would give each of you a different mission scenario. And what I've got here is like, did I hide the next one or not? Oh, so like this is one of the scenarios. An astronaut develops an unexpected and severe allergic reaction to a new food item introduced in the mission's resupply. Based on what you know, with limited medical interventions on board, The crew must manage the allergic reaction and adjust the food plan. So what do you do? So. So this, so why
I
do you?
use this for my class.
Yeah.
I'm gonna have my students working.
So what I would do, what I could do, so I've got different scenarios like that for each of the things that we talked about, and I would give you one. And what I would give you is not just the scenario like this, but I'd also give you the page that has the problem, the causes, the impacts and treatment. So it sort of gives you a hint as what the answers could be. Are you guys a game?
Yeah.
Okay, so perfect. So who wants radiation sickness? Okay. Who wants muscle atrophy?
I'll take that.
We'll take that. Who wants? I got latent virus reactivation. This is immune system thing.
I'll do that.
Okay. Isolation stress. Psychological change. Anybody? Going once?
Actually, I wanna do that one. I love psychology.
Good. We have radiation back on the table. Next one's bone fractures.
Yeah.
You want that?
Not the $3 one?
No, we already did food out. Or no, wait, hold on.
Heart palpitations, cardiovascular.
I'm sorry. Want to know, there's vision, there's heart palpitations, there's equipment malfunction.
Heart palpitation.
Okay.
I think heart palpitations for 5 minutes.
Okay, but
It's a daily double.
spend like 5-10 minutes. Let's say 5 minutes or so, and then we'll go around and we'll say, hey, you'll report out to the group.
We don't look at the second page.
Absolutely look at the second page. If you have ChatGPT access, use ChatGPT.
I was just thinking,
Absolutely.
well, that chat should be too.
Yeah, see what it says. And if it says something like, don't listen to Ken,
That's probably not too bad of a hallucination.
Well, I'm gonna do what Sarah did yesterday and be like, how to impress kids.
that's funny. That was funny. All you gotta do to impress Ken is smile and laugh. That's about it.
Laugh at my jokes.
So I'm gonna run out and grab another glass of water and I'll be right back. And do things hard about taking home his 900-page book.
Gotta sell.
Yeah.
I could have let you do allergic reactions. It's right there. I didn't have to, sorry. Laura, do I have to get out of here or are we supposed to wrap up by 52-ish, 53-ish? Okay. So we'll go 2 more minutes and then we'll report out.
I'll type as fast on my phone and dang it, I need my.
That's what dictation's for. Not too much fun for our Zoom participants, but. Oh well. One minute. Want to come in here? Good morning. Good lifetime. You're welcome. Oh. Oh.
You should come in.
Oh, you're here for the next one.
Yeah, no,
Well, no, we're answering how to deal with these space crises in health. Like health,
I read it.
space health crisis.
Is it bone density? I saw you quick.
No,
Oh, you big bone density. I should, I keep forgetting to talk about my polls.
yeah, I've used ChatGPT. ChatGPT gave me some good answers.
Okay, let's start reporting out. Laura, why don't you go, Laura, you go first.
So mine was what to do if an astronaut shows signs of extreme psychological stress and begins to withdraw from career activities. So I used ChatGPT. I said, help me figure it out. And they also they're not engaging in mission critical tasks. So they said to reassign critical tasks.
Okay. Oh, that makes sense.
To monitor erratic behavior. For the other astronauts to use calm engagement, have peer support, and then for them to use private channels to ground control to let them know. Have the crew conduct daily check-ins, and encourage, rest. This says fatigue or overstimulation might be a contributing factor. But they also said that they should have them connect with psychologists on Earth. Mission control should involve mental health professionals. And then, they said that they should have integrated technology to monitor mental health and use like tools like VR for relaxation, biofeedback devices, or cognitive behavioral therapy apps. They also said that a root cause could be something physical too. So they, lack of sleep, dehydration, poor nutrition, so that they should also have a thorough medical checkup.
Okay, so this is where the light therapy and all that sort of stuff.
Yeah, said team building exercises. Anyways,
Perfect.
yeah.
That's great. Great. Okay, next.
Yeah, so I had the immune system latent virus reactivation.
That's a tough one.
I guess. I think first off, I think quarantining the affected
Individual.
individuals or crew members, that I feel like that's probably the first step to try and not spread it throughout the entire space, team, I guess. And then try and apply whatever antiviral medication you may have to affected.
Yeah.
And I guess coordinate back with mission control
Right.
on how to move forward,
For lack of time, I'm not going to ask the questions about what you think about the quarantine thing, but there's only one bad.
Yeah.
So-
I know.
At best, they're gonna be able to wear a mask the whole time, but quarantining, and I don't know if you've ever done like a tour of space station or the VRISS app or something. There's not a lot of places to hide, kind of thing, so that would be a tough one, but I think, that as much as they can, they would like you said.
I guess like good, like hygiene practices.
Right, don't touch each other, that kind of stuff. Okay, next.
I had 9 months in microgravity. One of the astronauts experiences severe muscle atrophy, making it difficult to perform physical tasks required for a critical spacewalk.
Yeah.
First order of business, one, make a note, make sure that there's increased stress and importance on these physical fitness practices.
Right.
This situation doesn't happen again. Number two, get him exercising as quickly as possible, try to regain the
Let
strength.
me gain this one.
Three, determine how severe this or critical this spacewalk is. If he can't do it and can't get to the strength required in order
Yeah.
to perform it in the time needed, then we have two options. One, he can sit there and connect via radio or whatever with a more physically fit and coachable astronaut so that they can perform it in this place. Or two, they just need to find a workaround or whatever this,
Whatever it is, yeah.
because there's nothing really you could do, or they just have to push it. So
Reschedule, yeah.
really is reschedule it and
Perfect.
give them some time to figure it.
Great.
Next.
I have bone density loss and osteoporosis. My astronaut slipped and fractured his arm. Treatments are exercise regimes, nutritional supplements, pharmacological interventions and mechanical countermeasures. I think first line of business would be putting some sort of compression on the arm to increase blood flow to the fracture site, and then administering shelf-stable pharmacological interventions such as painkillers. These are medicines that would work on Earth and in space. I suspect that there's probably gonna be a long road to recovery, which would lead to other muscular atrophies
Yeah.
across the body with the inability to work out. I would try to get this astronaut back to Earth like as soon as possible, because it's probably a lost cause for a long-term mission.
A lot of these surgical, operations or a lot of just procedures that they do on people. Compression, like, CPR, there's nothing to push against, so now, you've gotta. Two people have gotta be secured to be able to apply forces. Okay, perfect.
Okay, so I have the astronaut, has heart palpitations. They begin experiencing heart palpitations and shortness of breath after exercising. So, it was actually really interesting that heart palpitations have been seen quite a bit. From the moment of takeoff, they can start seeing them in astronauts, but at that point.
They're sort of.
So Google AI suggests that you start with using common tactics that we would use here on Earth. So look at your electrolytes, look at your fluid. If your blood pressure is too high, then you do what you can, you try to use your physical positioning to try to lower it. If it's too low, use your physical positioning to higher it, and then or to raise it, and then as you try each of these things, you can systematically start to eliminate whether it's a innocent arrhythmia or if it's something more complex. And then if you eliminate the innocent, you go to more complex and you use the pharmacological interventions. And if that still doesn't work, you have to get back.
Great, perfect. Well, thank you. It's interesting to think through these things. And I've got a niece right now who's actually going to medicine, and she took a space medicine class at GW, George Washington University. And it's just fascinating, the different problems that the docs want to get involved with. And a lot of times the docs have got these perspectives on how to solve problems that the engineers could have used in their design process, or if the engineers had thought to include the docs earlier. And this is always a matter of communication across disciplines and stuff. So thank you very much for listening. Again, contact information. I'll be at the bar tonight or the brewery or whatever, so we could talk some more if you wish.
Come to Easter Divide tonight. We're giving 2 free drink tickets and have Jerry Stout Band playing. There's gonna be food, all free. And then we have the showcase this afternoon. So we have a bunch of people showcasing their different companies and startups. So you want to be here for that, and free headshots. And we have some just cool speakers the rest of the week. Block party Friday night, 2 Nashville artists,
Wow.
vendors, food, drinks. Gonna be awesome.
Perfect. Yeah, I'll be on stage again tomorrow at 9, talking about the future of commercial space. And now, hate to say it, but then I'll know what I'm talking about. Better than this time, but I appreciate you putting up with my presentation, and thank you very much.
Okay. Yeah. Find the mouse on here. I'm like-
Well, it's a special setup. It's a special setup.
I'm like, okay.
It's a special setup.
I don't understand that. I'm like literally, my nose are spinning right now.
Thank you.
And I'm like, I'm gonna do these workshops with my students, because I'm teaching a teams class and they have to solve problems.
Check. Give me 3 workshop.